Hello students, in this session we will try to learn Bitcoin network discovery process and synchronization. So in previous sessions we have studied uh, different Bitcoin topics like what is mining, verification, then task of miner, mining algorithm, proof of work. So now we have a idea how the Bitcoin network works and how the blocks are created and how the blocks can be added in the Bitcoin network. So students, we will try to understand the concept of Bitcoin network. So in previous sessions, we have studied how the blocks are created, how the blocks are added, what is mining, how the transactions are verified in the Bitcoin network, then how the proof of work mechanism works, that also we have studied. So Bitcoin network is a peer-to-peer network where nodes exchange transactions and blocks. So there are different types of nodes on the network, but mainly there are two types of nodes, full nodes and simple payment verification nodes. So we will try to understand about these nodes. But before understanding these nodes, we will try to understand, we will revise the things that we have studied in the previous sessions. What is Bitcoin network, how the blocks are created and how the blocks are added in the Bitcoin network. So we know that Bitcoin in Bitcoin network, every node has the copy of the ledger, or we can say blockchain. Every node, every participant has the copy of the ledger, and these nodes, if the node is full node, then these nodes will compete each other. These nodes compete each other to propose a new block, in the Bitcoin network. So these nodes are disparate to propose a new block in the Bitcoin network, because the nodes get the different benefits for adding a block in the Bitcoin network. So we know that nodes get reward for adding the block in the blockchain or Bitcoin, and because of these incentives, nodes compete with each other. Every full node tries to propose a block in the Bitcoin network or blockchain networks. So how the blocks are proposed? So before proposing a block, every node has the copy of transactions, and before finalizing the transactions are verified. Transactions are verified against certain rules. We have studied the 1617 rules. The rules are verified against the not rules, the transactions. Transactions are verified against certain rules, and if the transaction satisfies that rules, then the list of transaction is created, and every node has the list of transaction. So the nodes will bundle these transactions. They will gather. Nodes will gather this transaction, and they will try to put these transactions in the block. They will create the block, and these nodes will compete with each other to propose a block. So for proposing a block, node has to solve the mathematical puzzle that we know. Node has to solve the proof of work puzzle, or we can say mathematical puzzle. And for proposing a block in Bitcoin network, average 10 minutes are required. 10 minutes time is fixed to propose a block. So this mechanism is there in the Bitcoin to prevent the malicious nodes or attacker nodes from proposing a block, from adding a block in the Bitcoin network. So they have fixed this time, 10 minutes time, and for proposing a node, for not node for proposing a block, node has to spend lot of resources, a lot of resources in terms of hardware. Node must be powerful node. Node must have some powerful processing power. uh, Such kind of nodes can solve the mathematical puzzle. They can try to solve this mathematical puzzle, and they will propose a block in the blockchain, or we can say Bitcoin network. So for proposing a block, the node has to solve this mathematical puzzle, and for solving the mathematical puzzle, the nodes spend a lot of hardware resources, and for spending the resources, node will get a incentive. Node gets the award, reward, that we know, and for getting the no reward, the nodes will try to solve the mathematical puzzle. How the mathematical puzzle is solved, we know the rule. Whatever the hash, node will calculate the hash from the nonce, then hash of the previous block, then transaction. From all these nodes will combine these fields, nonce and hash of the previous transaction, and transaction to be proposed in this block, transaction to be placed in this block. From this it will calculate the hash, and this hash value should be less than the difficulty target. And if this hash value is not less than difficulty target, then node will vary the nonce. It will change the nonce. It will increment the nonce by 1, and it will it will try to change the nonce and try to get this value of hash less than the difficulty target. And if the node is able to solve the puzzle, if the node is lucky and node solves the mathematical puzzle, then node will propose a block. Node will propose a block, and node will broadcast this block to the peers, other nodes in the blockchain. And if other nodes agree, then the block is created, and block can be added in the Bitcoin network. So this process we have studied in the previous session. This is the main part of this Bitcoin network. Only the nodes can be added only through the mining process. If we want to add the node, several nodes in the almost all full nodes will try to propose a node, and the node who will be able to solve the mathematical puzzle, that node will propose a node, and that node will get the incentive, that node will get the reward for proposing the block in the Bitcoin network. So this process we have studied. Now in this session, we have to study when any node will join a Bitcoin network. So what will happen to this node? How this node will synchronize? How this node will synchronize with the Bitcoin network, and how node will discover the network? So that we will study. So there are two types of nodes, full nodes and simple payment verification nodes. So first we will study what is this full nodes and simple payment verification nodes. So first type of node is full node. Full nodes can do almost every possible activity. The full nodes can do almost every permissible or possible activity in the Bitcoin system. A full node can do the mining of transactions. Full node can do the verification of transaction. Full nodes can broadcast the transaction. Full node can provide the wallet services. The full nodes also provide the routing function. The full nodes can also propagate a block in the Bitcoin network. So the full nodes also provide the routing function to participate in and to maintain the Bitcoin node. So to become a full node, the node has to download the entire blockchain. The node has to download the copy of the ledger. Node has to download the entire copy of the blockchain database that contains the entire transactions, and all the blocks. So it will it has to download the copy of the entire ledger, or you can say blockchain. Also the node must stay permanently connected. So this full node must be permanently connected to the Bitcoin network, and this node must hear all the transactions. It will hear all the transactions, all the activities taking place in the Bitcoin network. So it is important that if you have a good network connection and good storage capacity up to 200 GB and at least 2 GB RAM dedicated to it, then such type of nodes, such type of machines can become a full node in the Bitcoin network. Uh, then second type of node in the Bitcoin network is simple payment verification nodes. So these nodes are not powerful as the full nodes. Simple payment verification nodes cannot mine new blocks. These nodes cannot propose a new block. They cannot create a new block. They cannot propose a new block. But they can simply verify the transactions. They can simply verify transactions by using simplified payment verification process. So these type of nodes are sometimes called as thin clients. They can participate in pool mining. They can participate in pool mining means when there are many nodes. So for this simple verification mode, it is not possible for simple verification nodes to propose a new blocks. But if there are some other nodes come together, and these nodes, the pull up nodes can propose a new block in the Bitcoin network. These nodes can participate in pool mining, where there are many nodes. They are trying to mine the new blocks. These nodes will come together, and these nodes will try to propose a new block in the blockchain. So these simple verification nodes can participate in such kind of pool mining. So lightweight nodes can help the verification of the transaction. These nodes can help the full nodes for verification of the transaction. So full nodes can assign a task of verification to this simple verification node. So these are the two types of node in the Bitcoin network. So now students, we will try to learn the Bitcoin discovery protocol and block synchronization messages. So when the node will join to the network, and either if the node is already in the network, to perform a various functions in the Bitcoin network, node uses a 27 types of protocol messages. There is a protocol designed for Bitcoin network, and this protocol has 27 types of messages, and these messages are likely to increase. The number of messages may likely increase over the time as the protocol grows. So the most commonly used protocol messages and their explanation, I am trying to explain some of the protocol messages. It is not possible to explain all the protocol messages, and it is also not necessary for us to study all these different types of protocol messages. But if the students are interested, they can go into the details of these protocol messages and how the communication takes place between the nodes. This is from the programmer's point of view, how the Bitcoin network is designed and how the nodes communicate with each other. When the node will join to the new network, what will happen, what type of messages are exchanged. Then if node will try to propose a block, what type of messages are exchanged. So in this session, we are basically trying to learn the Bitcoin discovery protocol and block synchronization, how the Bitcoin synchronization will happen. We are not going into the details of all the functions that will happen through the exchange of these messages in Bitcoin networks. So first type of protocol message that may be exchanged, that is version. So this is the first message version. This is the first message that node sends out to the network when the node will join a network. Node will advertise himself. Node will send its version number to all the peer nodes in the Bitcoin network. So this is the first message that a node sends out to the network. By sending this message, node will advertise its version and block count. The remote node, then all the nodes in the network will listen to this message, and the remote node then replies with the same information. The remote node will also reply with the version and the connection, and after exchanging this version, the connection is then established. The connection is established between the remote node and this node who has sent its message on the network. Then next message, protocol message, is version acknowledgement. This is the response of the version message. This is the response to the version message that the remote node has accepted this request, and remote node is also replies with the version number. So this is the acceptance of the connection from the nodes in response to the version protocol message. Then third message, the third protocol message is inventory, INV. This is used by the nodes to advertise their knowledge of blocks and transaction. How many number of blocks are there, whether the node is synchronized with the all blocks, whether the node has the information of all blocks. Node will publish, node will advertise its knowledge about the blocks and transactions in the network by using this INV, or you can say inventory message. Then next protocol message, Bitcoin protocol message, is get data. This is a response to the inventory message requesting a single block or a transaction identified by its hash. Then get blocks. This returns an INV packet containing the list of all blocks starting after the last known hash, or 500 blocks. So the last known block after the last known block in the blockchain, or you can say Bitcoin, this get blocks returns an INV packet containing the list of all blocks. So get headers, this is used to request the headers in a specified range. In Bitcoin network, when the node will join to the network, node has to download the copy of the blockchain from the neighboring nodes or from the peer nodes. So sometimes if it is not possible to download all the copy of the ledger at a time, so node may request the headers instead of downloading all the transactions and all the blocks. Nodes may request the headers. We know that the block contains the headers, and this get headers is used to request a block headers in a specified range. Then next message is TX. TX, this is used to send a transaction as a response to the get data protocol message in the this communication between the nodes. Then block, next message is block. This sends a block in response to the get data protocol message headers. So this packet may return up to 2000 block headers as a reply to this get headers request. So then get address, this is sent as a request to get information about the known peers. So in this Bitcoin network, the nodes are known by their addresses, and before starting the communication with the node, we must have address of that node, and communication will take place with the help of address. So if the node wants to communicate with some other nodes, so first it has to get the address of that node, and after getting the address, then he can start the communication with that node. Then address, this provides the information about the nodes on the network. So AWDR, this provides the information about the nodes on the network, and it contains the number of addresses, and address list in the form of IP address and port number. So these are the different types of messages that can be exchanged. We have taken review of some messages, not we have studied all the messages. There are 27 messages, and list of these messages are increasing day by day. As the Bitcoin network will grow, number of messages will exchange. And from the programmer's point of view, if you go into the details of this blockchain, how the blockchains will be designed, how the communication between the nodes will take place, so it is important to study these details and protocol messages that are exchanged between the nodes in the blockchain, or you can say Bitcoin network. This is the Bitcoin discovery process protocol that we have to study in this session. How what will happen when the new node will join to the network. So when a Bitcoin core node starts up, when the node will start up, first it initiates the discovery of all the pairs. It will try to discover the nodes, all the peer nodes in the network, and this is achieved by querying the DNS seeds that are hard coded onto the into the Bitcoin core client and are maintained by the Bitcoin community members. The Bitcoin community members will maintain the information about the nodes peers in the Bitcoin network. So this lookup returns a number of DNS or records or number of peer nodes in the Bitcoin network. So the Bitcoin protocol works on TCP port number 8333. Then by default for the main network, and TCP 18333 for testnet. In block information, blocks data structure, we have studied one initial number of 4 bytes, magic number we call, and from that magic number we will come to know the originate of message, from what type of network the message is originated, and there is no more significance of this magic number. This magic number only indicates the originate of this originate of the Bitcoin network. So we will study how this Bitcoin discovery process will happen. So students, try to understand the concept of this Bitcoin discovery. The process when any node will join in network, when the newly join node, when the some node will join a Bitcoin network, what will happen? How this node will discover a Bitcoin network, and how we can this node can communicate with the other nodes. That we have to we will try to understand by using this Bitcoin discovery process. So first the client, the node that will join a network. First the client sends a protocol message version. It will send a first version message that contains various fields such as version, services, timestamp, network, address, nonce, and some other fields. So first the node will advertise itself by sending the version message. Then remote node responds with its version message. The remote node will reply with its version message, followed by a version acknowledgement message. And after getting this version acknowledgement message, the connection is established. Connection is established between the requesting node and remote node. And after that, the node has to download the copy of the ledger. Node has to download the if the node is full node, then node has to download the copy of the blockchain, copy of the ledger, and then only node can do the mining and other different types of operations in the Bitcoin network. So after establishing the connection, after exchanging this version message and this version acknowledgement, after this node will use the get address and address messages, because communication with the remote node will take place with the help of only address. So node will try to get the address of that remote node, and after exchanging the addresses, exchanging the addresses between the requesting node and remote node, the connection is established, and they can exchange the information. What information may be exchanged? The node may request a copy of the blockchain. If it is not possible to download the full copy of the blockchain, it will request the errors. So such type of information nodes will exchange between the among them. After getting the address, either of the nodes can send a ping message to see whether the connection is still active. So node will use this ping message, ping message to see whether the connection is still active or not. So this ping message is used frequently to see whether the node is active in the network or no. So the network or not. So the get address and address messages are types defined in the Bitcoin protocol. So we will try to understand the how the communication uh, the network the connect what will happen when the node will join to the network. So in previous session, previous slides, not session, in previous slide we have studied there are two nodes, node A and node B, and node A wants to join a network. So it will send a version message, and it will advertise itself by sending the version. Then remote node will reply with the version. Remote node will also reply with the version. Then after getting the this version from remote node, the node A will reply with the message version acknowledgement. You can see this version acknowledgement, and this node B, which is the remote node, that will also send the message version acknowledgement. Then next task is to know the address of the remote node. These nodes will exchange the address, and for exchanging the addresses, they will use the message get address and address. So this how what will happen. This is the process. This diagram illustrates. This diagram explains how the communication will take place between the nodes and what will happen when the node will join to the Bitcoin network. So when the node will join to the Bitcoin network, it will first advertise itself by using the version. Then remote node will reply with the version. Then version acknowledgement messages are exchanged between the requesting node and node, remote node, and then they will exchange the addresses. And after getting the addresses, then further communication can take place between these nodes. Then next is when the nodes will when the new node will establish the connection in the Bitcoin network. So what will happen? What is the next task? So what will be the next task? If the node wants to be a functional node, if node wants to do some operations, mining, proposing a block, verification of the block. So for that purpose, node must have a copy of the ledger or blockchain. So node, after establishing a successful connection in the Bitcoin network, node will try to download the copy of the ledger. After establishing the connection, block download will begin, and when the node will start, it checks whether the blockchain is fully synchronized already. The new node will try to get the copy of the blockchain from the other node, and first it will check whether that remote node has the full copy of the blockchain or not, whether that copy is fully synchronized, up to date or not. If that copy is up to date, if that copy is fully synchronized, if the copy of the ledger is fully synchronized, then it will request for that copy from that remote node. So if this copy is not synchronized, when the node starts up, then it will request the headers from the other peers using the get headers message, and it will check if the blockchain is fully synchronized or not. So it listens for new blocks via inventory messages, and if it already has a fully synchronized copy of the blockchain header and all information, then the node will request blocks using the get data. Using the get data, node will request the information of the blocks and copy of the blockchain from the peer nodes or from the remote nodes. So the node checks whether the header chain has more headers than the blocks. If the header chain has more headers than the block, it means that some blocks are missing. then it will request for that missing blocks by issuing the get data protocol message. So there are different types of protocol messages: get data, data, get address, version, and this type of messages are exchanged between the nodes for communication between the nodes, for verification, for mining, for proposing a new block. So such type of exchange of messages will take place in the Bitcoin network. So those are interested in programming, the students can go into the details of this, how the communication will take place between the nodes in the blockchain, or we can say Bitcoin network. So this, you can see this process is explained in this diagram. There are two nodes, we can say this sync node and this IBD node. This IBD node is the node who has joined a network first time. This node will request a this node will try to download a copy of the blockchain from the sync node. So for that purpose it will send a message get headers. Then this sync node will reply with the headers message. Then after getting the copy of headers, then it will try to get the data from the sync node. So it will try to it will use the message. It will send the multiple messages, get data messages, and from the nodes, the synchronization node, sync node will reply with the blocks to this. So in this way, this newly joined node will try to get the copy of the ledger, copy of the blockchain from the Bitcoin network. So this is how the messages are exchanged between the nodes. So synchronization process, in this synchronization process we have studied in the previous slide. This previous slide shows how the synchronization will take place. The Bitcoin block synchronization process between the two nodes on the Bitcoin network. So in previous figure, node A, node A is called initial block download node. Try to understand this concept. IBD node is nothing but the node who has joined the network newly, and that block don't have the copy of the ledger. This block don't have the copy of the blockchain. So this node will try to get the copy of the blockchain, copy of the ledger from the peer nodes, because in Bitcoin network, in blockchain network, every node has the copy of the blockchain. So this initial block download node, IBD node will try to get the copy of the ledger from the other nodes. So in previous figure, node A is called IBD node, initial block download node, and node B shown to the right side is called sync node. And IBD node means that this is the node that is requesting the blocks. This node is requesting for the copy of the block ledger, copy of the blockchain. And sync node means the node from which the blocks are being requested. Sync node is the remote node from this node. The IBD node will get the copy of the blockchain. So this process this process will be started by node A. Node A will request the copy of the ledgers by using the get headers message. Then the sync node will reply with the headers. After getting the headers of the block, then node A will reply for the node A will request for the copy of the blocks, and by sending the get data messages, and in response to the get data messages, sync node will reply with the data. So this is how the node A will get the copy of the ledger from the sync node. This is synchronization process, how the synchronization will take place between the nodes in the Bitcoin network. So students, you can see this is the script. This figure shows how the messages are exchanged, different types of protocol messages that we have studied in this session: version acknowledgement, then get address, get headers, get data, then inventory messages, then get data, ping message. So these are different types of messages that are used for synchronization and Bitcoin network discovery. So there are number of 27 types of messages, and this number may increase in the future as the Bitcoin network will grow. So students, we will stop here. In this session, we have studied the blockchain discovery process. What will happen when the node will join to the network, and how the messages are exchanged in the Bitcoin discovery process, and during the synchronization of the network, how the nodes will exchange the different types of messages among themselves, that we have studied. So today we will stop here. Thanks for watching the session. Goodbye.